Recall that in calculus, you learned that a function is called increasing if x values on x-axis increase, you see an increase in y value. So as long as x1 is less than x2, your y1 is less than y2. For example, consider this function, exponential function, f of x equals to 2 to the power x. This is an increasing function. For example, you can take on different values. x1 is less than x2. You can say that, hey, like -1 is less than 1. Am I right? So what is f of x1? F of x1 is f of -1, which is equal to 2 to the power -1 or a half. What is f of x2? F of x2 is f of 1, which is 2 to the power 1 or just 2. So of course, a half is less than 2. So f of x1 is less than f of x2. We see the increase from left to right, the graph increases. We have the same observation for sequences as well. A sequence like an is called an increasing sequence if for all values in the domain a sub n is less than an plus 1. We can use the exact same example here. In this example, consider an equals to 2 to the power n. For any natural numbers, 2 to the power n is always less than 2 to the power n plus 1. Don't believe me? You can select different natural numbers and show that 2 to the power 1 is less than 2 to any power. So again, you can observe the behavior on the graph from left to right, the graph increasing. So 1, 2, 2, 4, and this is the behavior of the graph that you have. You see an increase in the graph. However, again, from the recall, remember that if you have a function f of x, we call it decreasing function. If x1 is less than x2, it means that you have increase in your x values. You have decrease in y values. Then you can complete f of x1 is more than f of x2. The same behavior for a sequence. A sequence is called decreasing if for all natural numbers or numbers in the domain, an is more than an plus 1. Let's take a look at the example from note. I have 3 divided by n plus 5. Is it increasing? Is it decreasing? Now remember the behavior of the graph. The graph behaves like this. So we expect to have a decreasing behavior. You can use Desmos and graph function 3 divided by x plus 5, which going to resemble the same behavior for the sequence. The function, the graph is decreasing. So for now, from algebra, I know the behavior is decreasing, but I need to show this as a decreasing function. From algebra or number theory, we know that n is less than n plus 1. This is obvious. Add 5 to both sides. So n plus 5 is less than n plus 5 plus 1 or 6. Remember that 2 is less than 3, but a half is more than a third. So if I flip this, I get 1 over n plus 5 more than 1 over n plus 6. Now multiply both sides by 3. Three divided by n plus 5 is again more than 3 divided by n plus 6. This is your an, and this is an plus 1. So we just showed that we have a decreasing sequence. Remember that you could take the derivative and show that the derivative is negative. Then you have a decreasing function as well. This is another criteria that we're going to discuss later. One last thing, if you have a decreasing or increasing sequence, we call that a monotonic sequence. Is a sequence which is increasing or decreasing.